Okay, two streams of water are mixed to form feed to a boiler. So the first step is to extract all the information. So we start to draw the schematic diagram to represent the process that easier for us to solve this problem later. So we have two fish. So just draw two. And then we have this. Okay, the given information. We have the mass flow rate. So equal to 1 kg at 30 degrees Celsius, and M2 is 175 kg at 65 degrees Celsius. And then the feed, okay, this is feed to the boiler. Okay, the mixture, our system is mixture. And then the pressure is given 70 bar. Exiting steam emerge from the boiler through, okay, the diameter is given. And then calculate the required heat. So we need to calculate the required heat in the mixture. The unit is kilojoule per minute. Okay, what other information? What is the other information given? Is neglect the kinetic energy. That's mean we're gonna have this kinetic energy equal to kinetic energy at outlet. So we neglect the inlet, so outlet. Okay, the overall mass balance is half Q minus work equal to delta H plus delta kinetic energy plus delta potential energy. Okay, and then the second is to, okay, second is to write out, okay, we need to make an assumption to simplify this equation. So since this is a mixture, there is no moving thing here, so we can ignore the word here. And also we don't have this potential energy. So it can be simplified to Q equal to delta H plus delta kinetic energy. So we need to find the value of enthalpy here. So how can you find this value? So maybe this is H1, H2, and then your H3 here. Okay, so we need to refer to the reference table here. Let me share to you. I already upload this reference table at your time, so you may refer to this. To solve that problem, we have the condition of saturated steam, right? So you may refer to this table B5. Okay, the given temperature is at 30 degrees Celsius. The enthalpy is we consider for water because it is still a liquid stage. And then the second step at 65. So you may perform the interpolation between this temperature to obtain the value at 65 degrees Celsius. The information given is pressure. So you may refer to this. We have the, for the pressure, if the given information is pressure, so at 17 bar, okay, here we have 17 bar. Okay, the information is about the saturated steam, so it already turns to the steam, so we may refer to the column for the steam here. Okay, back to the question. So we can have this information about the enthalpy. So H1 is from the table, H1 is 1 to 5.7 kilojoule per kg. And then H2 is 271.9 kilojoule per kg, and H3 is 2793 kilojoule per kg. Okay, and then we can get this delta H here is find the unknown equal to output MIHI minus input MIHI. So you can calculate this. MI here is also we need to perform the balance. So M3 here, you can get the M3 by submission the M1 and M2. So M3 is 295 kg per minute. So to solve this, output here we have 295 kg per minute. And then H also, we already find the value of kilojoule per kg. And then minus, so we have 10 kg per minute. And then 125.7 kilojoule per kg. And we have 175 kg per minute. And also times 271.9 kilojoule per kg. And then the answer is delta H is 7.61 times 5 kilojoule per minute. And then the third is to determine kinetic energy. Okay, the fourth is to determine the kinetic energy. Since it equal to output, the kinetic energy at output, that is given, you need to determine the U, right? So U equal to V over A. And then we can determine A equal to pi r square. And then you can insert the value 0.1416. R here is 3.0 cm square. And then we need to convert the unit. 2.83 times power of minus 3m square. And then you can determine your U here from the V. Okay, the V given here is, we can consider at output here. From our calculation, we have 229 kg per minute minus 2. Okay, because this is a kg per minute, so we need to use the information of density. So you need to find the density at this condition at 70 bar to obtain the density of steam. So the density of steam is 0.1166 kg. So over kg per minute. So kg per M3. Can get this 60 second 1 minute 2.83 times m square. Then the answer is 202 m per second. Okay, once we already determine the U here, okay, delta or kinetic energy equal to 1 over 2U to M3. So you may insert this value 1 over 2. So we have 202 M square. And we need to times this. M here. Okay, M here, we you have kg per minute. So please standardize the unit. So we have 1 kg m per square equal to Newton. And then we can get to cancel the Newton. So equal to kilojoule. Finally, we can get the answer is times 3 kilojoule per minute. And then your del Q equals to delta H plus delta E, or kinetic energy equal to 7.67 times kilojoule per minute. So this is how we solve our first problem.